Okay, welcome to uh, JC Connect. In the previous class, we were discussing about the very important test, that is chemical composition test. So normally, our cement is consists of the composition of silica, that is calcium oxide. So it is in the form of hydrated as well as unhydrated form. Then alumina, that is Al2O3. Then Fe2O3. Then how exactly the how exactly this can be calculated? Just a minute, the pad is not working. Just hold. Okay. So in the previous class, what I told is that uh, that is SiO2, uh, calcium oxide, that is lime as well as unhydrated lime. So Al2O3 and Fe2O3. These are sometimes this Fe2O4, it will be in the form of Fe3O4, Fe2O3 or Fe3O4. It will be in the form of it will be in the form of it will be in the form of either it will be Fe2O3 or it will be in the form of Fe3O4. Okay. So I was telling about the fineness test, and I showed that the shape of the and the size of the particles can be determined with the help of SEM and BET method. So BET is uh, it is used for to measure surface area, that I already told. Okay, then how this um, images images of SEMs look like. Here you can see that this is actually I only carried out in our advanced laboratory uh, when I was doing my doctoral degree. So just I take that pictures to show that how exactly the images looks like and how exactly shape of the particles can be calculated. So forget about this. This is what the raw uh, material without processing. Okay, it is the image. The first one is a image. It is uh, actually related to raw laterite. So the raw laterite stone, it is powdered and it is taken image in scanning electron microscope, and you can see the here, um, it will be the width, total width of this image itself is 5 mm. Just imagine the total width of this image is total 5 mm. Okay, then magnification, just check it out, it will be 90 kx. Okay, 90 into 1000, um, then that much x resolution you are going to get. See, this, forget this. This is a law, right? Law, you cannot find any particles here. Suppose if you find coming to this image B, you can see that the particles are of this shape. You can see small sizes are there. So this kind of observation has to be uh, made, or it has to come with the cement. Even if the cement is there, it has to look like this. Okay, similar image. Okay, then if I want to measure the size of this particle, you can see this is one particle, this is also one particle, this also. So it can be measured easily. Here different size of the particles are there, of shape circular in nature. In this image you cannot find any shapes which are circular in size. Okay, but here you can see that what kind of shapes are there. Okay, almost in some part, at this part, you can see that the agglomeration of the particles has happened. Means it is all the particles are clubbed up in some positions. Okay, this has the typical images of your SEM. So through this you can see that even smaller particles. See, whatever this much distance, whatever he has given here. Okay, this much distance is of 200 nanometers. So similar size if you draw anywhere here, okay, with a similar size if I draw it, you can see how many number of particles are there. Here you can see, here you can see, around more than 3 to 4 particles will be there with this much of distance. With this much of distance you can find this much of distance anywhere. If you draw it anywhere, if you draw this much distance, normally you can find smaller the particles, like 3 to in between you can find in a 200 nanometers. Just imagine it is nanometers. Okay, in a 200 nanometer stretch you can find 4 to 5 particles. 4 to 5 particles. It means that if you divide it by 5, so normally you will get roughly around 40 nanometers. See, this much size of the particles, normally it will be there, um, even if you are um, going with the fineness of the cements. So normally fineness of the cement, he said that least will be 1.5 micron to it will be somewhere around is mentioned 100 micrometers. Okay, if you convert that into even the smaller size also, you will get it. But if you want to fineness of the cement, if you want to find out accurately, if you want to find out the um, shape and size of the particles, we should go for the this kind of images, that is scaling electron microscopes. Okay, be it you won't get any images directly, you'll get the value. It is in terms of how much meter square per kg of the cement. Okay, then we started with the chemical composition of the cement, and the main composition, it will start with the SiO2, L2O3, then Fe2O3. So then we have calcium oxide, that is hydrated. And so how exactly this chemical composition can be calculated? So I was telling about previously, that is the EDX. So this is one kind of experiment uh, which you use to find out elemental elemental composition. So elements means, for example, if we have I said that Fe2O3, Al2O3, then SiO2, then you have um, CaO or CaOH twice. Okay, the these are, suppose if I want to find out how much Fe only it is there, how much oxygen is there, how much Al is there, individual components, elements, how much Ca is there. So if I want to find out that, okay, I have to go for the EDAX analysis. So in this you can see that, you can see here the peaks you will get it like this. Carbon is there, Fe is there, Ti is there, oxygen is there, Al is there, Si is there. Okay, small Ti it will be there, Fe is there, Fe is there. So like that, but it is FER in different forms. Whatever this Fe is different from this Fe, and this Fe is different from this Fe, and this Ti is different from this carbon. Carbon is different from this Si. Okay, see, form of Fe is different. Sometimes here Fe may be, it may be in the form of Fe2 plus. Here it may be in the form of Fe3 plus. Maybe here it will be in the form of Fe0 and in the form of Fe0. Okay, like that you will get a graph like this if you do it in EDAX. So if you want to find out what exactly the elemental composition of the cement, chemical composition, so then you have to go for this EDX analysis. Okay, this is how you will get the graph, and you will get the by percentage weight also. Okay, if you are finding out, then suppose directly if you want in terms of mineralogical compositions, mineralogical mineralogical compositions mineralogical composition, so like L2O3, SiO2, then Fe2O3, directly it in the form of either it or Fe3O4. So you have to go for the XRD pattern, that is X-ray diffraction, XRD pattern. So X-ray diffraction you have to go. So in this you can see, okay. So here with this you can see, here you are getting smaller like this it is going, but at some time it is going peak, like again it is going like this, and you will get some peaks, and again it will go, again it will. So whatever the peaks you can observe here, this peak and this peak, these are nothing but some of the mineralogical compositions which you can observe. Okay, there is a always some standard protocol is there uh, in this X-ray diffraction, that is how the intensity is varying with 2 theta degree. If I want to explain it very quickly, suppose what will happen is that, if assume that you have the Al2 is there in this compound, so normally the X-rays will be there. X-rays is going to hit to this particle. Okay, X-rays, assume that this is a particle, X-rays are going to hit this particle, and if SiO2 is there, it will deviate with some angle. If Fe2O3 is there, it will deviate with some angle. If FeO is there, it will deviate it with. So the angle can be measured. So the angle can be measured with the help of X-ray diffraction. So all the whatever we are talking about this, the 2 theta degree, uh, degree of diffraction, what we are talking about. So these are totally different from each of the mineralogical compositions. This is one figure which you can observe. Similarly, There is also one more figure. You can see that here it will be polyphenols, FeOH, megamite. See, this is not typically about the cement. It is for the different materials. But how exactly the chemical composition can be determined? How exactly the graphs you will get it through an advanced equipments. Advanced equipments. Of course, the equipment's cost is in terms of crores. Normally, it will be whatever the equipments are there. If you want to find out it, it will be in terms of crores together. But still, you can find out without the advanced equipment. Also, you can do it in the laboratory with the help of the titration method. What I told, you can do it by using a gravimetric method. That is, in, even in the environmental lab, we can do this gravimetric method. Gravimetric method of determination of chemical composition. You can determine SiO2, you can determine Fe2O3, you can determine FeO, and you can determine with the help of the, you can determine Al2O3. So also some of the leaching methods are there, and now they have developed leaching method. So what normally we'll do it in this leaching method is that if you take the cement in leaching, what we'll do is that we'll extract only SiO2 and we'll find out it, and sometimes we'll only extract Al2O3 and we'll find out it, and in only sometimes we'll only go for FeO, and um, we'll see that how much it will be there. Okay, so different leaching methods will be there, and leaching methods also will use it. For example, if you want to find out the SiO2, so we'll use HCl, that is hydrochloric acid, as an leaching agent. Leaching agent. Okay, if I want to find out the SiO2, again, if I want to find out Fe2O3, again HCl will be used, but Al2O3 will use different. Okay, we'll go for H2SO4. Okay, whenever if you are find outing the chemical composition in terms of oxides, normally we are discussing about the SiO2, Fe2O3, FeO, and Al2O3. This is the oxides of elements, all are mineralogical compositions. If you want to find out it, so you have to use this XRD pattern. Okay, and you can confirm with um, one more method called FTIR. Okay, even with the help of the FTIR, you can confirm the uh, which are the functional groups that are present in functional groups that are present in the any of the sample. So how exactly it will be interlinked? For example, we said that okay, FeOH is there. Okay, here OH is in functional groups. Okay, suppose if FeOH is there, OH is in functional groups. Okay, so like that, you can confirm with that. Okay, Fe is also there, and OH is also there. If OH is there, if it is interlinked with Fe, so then it is also interlinked with the previous. So it is only for the confirmation that what kind of functional groups that are present in the sample. So you'll get the graph like this. Okay, and always it will be with the transpedance and the wave number. Um, it will works on the principle of Beers and Lambert's law. Beers and Lambert's law. See, and you might be studied the Fourier transforms. The principle behind this, it is the Fourier transforms. So the full expansion of this is Fourier transform infrared spectroscopy. Okay, what will happen? What is this Beers and Lambert's law? So, how exactly the definition? What it will say that the absorbance is directly proportional to the concentration, or transmittance is reciprocal of the concentration. Means, for example, I say it is FeOOH is there. Okay, FeOH is there. What it will use that when infrared means you might be it will work on the principle of electromagnetic spectrum. You just open any electromagnetic spectrum. Okay, in this you can see that starting you have um, x-rays will be there, gamma and beta rays will be there. So then after that you have UV rays will be there. Then you have visible range is there, visible light will be there. Then after that you have IR region. Okay, so X-rays. So two things has to be kept in mind, that is frequency and wavelength. Frequency and wavelength. Okay, normally the wavelength will decrease as it move towards from left to right. Okay, that is wavelength. Then frequency will decrease. So these are two are reciprocal. So each of this electromagnetic spectrum, okay, if you just open that, okay, normally up to UV region it will start from 190 nanometers wavelength till it will be UV range. If you select the UV range, if you select UV range, it will be from 190 nanometer to around 360 nanometers. So then visible it will be from 361 to roughly around 700. So from IR infrared it will be 700 to 1100 nanometers, and whatever the X rays, laser lights, and gamma rays, beta rays, it will be lesser than 190 nanometers. So lesser than 190 nanometers. So you can find UV rays, sorry, X-rays, alpha, beta, gamma, laser. So these are all it will be less than 190 nanometers. So if you just open it, so you'll come to know that what will be open that electromagnetic spectrum. You can find out that. Okay. So all this even X-ray diffraction, what we discussed earlier in the previous slide. Okay, the X-rays are responsible for that. X-rays are responsible for finding out the finding out the uh, X-rays are responsible for finding out the chemical composition of chemical chemical composition of any of the materials. Okay, here also you can see on y scale it is transmittance is there, y it is in x scale it is wave number is there. So we are, and also we are discussing about the Beers and Lambert's law. What will happen is that when the light is going to hit to this, okay, FUH or FUH, if that is present in your sample, or if it is present is CaO or CaOH twice, if it is present, if it is going to hit whatever light, if it is going to hit, so then this element or this composition is going to absorb some of the light. Absorb the light or the rays. It is going to absorb light or the rays. Okay, so that is nothing but absorbance. What we are talking about. This material is going to absorbance. Suppose what will happen is that, so here light is coming. So here you have one compound is there. What will happen is that 100% light, if it is going to hit to this, okay, assume that if it is 50% is absorbed, then remaining has to be, either it has to be diffracted or either it has to be transmitted 50%. 50% either it has to be reflected back, okay, or it has to be transmitted. Okay, most of the time transmittance means 50% it is absorbing, 50% it is transmitting on the other side. Okay, so like that, it has one concept is there, how exactly each of the minerals what we are talking about, it's having its different absorbance. So this is going to absorb in very less, this is also going to absorb in different way, and this is also going to absorb uh, in a different way. How exactly this one, it depends. So if the concentration of this, if the concentration of this um, mm, for example, if FeOH is there, okay, if the concentration is more, okay, even you will get the absorbance also more as for our principle. If in terms of what you can say, uh, 2 molar or 3 molar, something like, if the concentration, I'll explain that what exactly molar or 3 molar concentration. If that one is more, you will get the absorbance also more. Okay, so we'll discuss this, but as for now, um, the transmittance, sometimes you'll get here absorbance, it will be absorbance. Okay, if it is absorbance, the peak will be reverse. If it is absorbance, the peak will be like this, it will come like this, but here you can see the peaks are like this. Okay, the peaks are downwards, but here the peaks will be upwards in case of if absorbance is on the um, y scale. Okay, at overall, no need to in detail, overall what we can do is that how exactly this uh, chemical composition of any of the material can be um, calculated based on the advanced equipments. So even if you do it in our using titration method, it is not the correct method of doing the analysis. So that is why always send the sample to NABL accredited laboratory. So definitely you will get the good uh, mm, results. And we'll move on to the strength characteristics. So the strength characteristics are also very important, uh, as um, any of the things we will discuss always will try to correlate with the strength aspects only. Least we'll bother about the other properties. Okay, the primary importance, whatever the ratios and whatever the changes you are doing, water to bind ratio or whatever the things you are doing it, ultimately we need the strength aspects and always will concentrate on strength aspects only. Okay, so how exactly the strength can be calculated? Of course, we'll move a little bit fast from this because you already many times you might have learned, and in projects also you might have did it. Okay, so the cement paste strength is typically defined in three ways: compressive, tensile, and flexural. Um, we can do. You are very familiar with the compressive as well as tensile. So flexural, little bit maybe less experiment you might have calculated, you might have done. Okay. So these strengths can be affected by a number of items, including water to cement ratio, cement to fine aggregate ratio, type and grading of the fine aggregate, curing condition, size and shape of the specimen, loading conditions, and age. Okay, all these things are depends on the strength characteristics. Okay, you might be knowing how exactly the molds will be prepared. For that, you started you'll prepare on mix design. For that mix design, you will add the proportional, and you will try to correlate with whatever the mix design you did it. Okay, you have to prepare the molds. In that molds you have to fill the proper uh, ratios of cement and all those things. Then you have to take it out. Then after that you have to go for the curing for 7 days, 14 days, 28, 21 or 28 days, like that it will be there. So then strength, first one, that is a compressive strength. The cement paste, they consisting of one part and three part of standard sand, um, water by weight, is placed in a 7 centimeter mold, and the specimens are water cured for various ages for testing. The mortar specimens taken out of the molds are subjected to compressive compression to determine the uh, strength. Then the compressive strength test is conducted on a mortar cubes after finding breaking load on compression. So that is P max. Compressive strength is calculated by, that is P max by area. That is where area is 50 centimeters square. That you have to calculate it. That's it. So the average of the results found by testing six specimens is normally of the mortar cubes. Go for minimum six specimens, and whenever you are doing it, go for average of, even if you go for 12 also no problem. So don't go beyond six specimens. Six specimens. Okay. Uh, this um, the other compressive strength details we'll discuss in the next class. If you have any doubt, you can ask related